Looks good. All right, just in time. Perfect. Okay, so this is a 45-minute session. I will aim to speak for approximately 30 minutes, and then we will have 15 minutes at the end for questions if my arithmetic is correct. So one of the things we're trying to achieve with DevOps is increasing enterprise agility. So enterprise agility is not the same thing as agile agility. This is how The Economist defines enterprise agility, or the obstacles that The Economist lists to achieving enterprise agility. The main obstacles to improving business responsiveness are slow decision-making, conflicting departmental goals and priorities, risk-averse cultures, and silo-based informations. So I've never had that problem anywhere I've worked. Maybe you have a friend who has that problem. So I finished my keynote this morning talking about the journey, so we're going to start with that now. So just to recap, what I said was, in order to get this stuff done, you need to agree and communicate measurable business goals. Why do we want DevOps? What's the business benefit? Do we want to release faster? Do we want to reduce costs? Do we want to improve quality? Faster time to market? Define those things in measurable terms. Not let's get faster, let's reduce lead times by 50%. So measurable business goals. We're going to give teams the support and resources they need to experiment, which means giving them good people, giving them capacity, giving them money, giving them permission to try a bunch of things that don't work out and keep going when they fail and learn. We're going to have to talk to a bunch of other teams. That's the number one DevOps cool trick. What's that thing they say in these articles, like the clickbait articles? Yeah, one funny trick you won't believe. Number 3 will surprise you. Achieve quick wins. So it's going to take you years to get to the goal, or to change everything. Probably years past we're all dead, frankly. It's a long time frame. What you've got to do is find ways to achieve quick wins along the way and keep going. So I also said this morning, people love focusing on tools and reorgs. That's not normally the problem. Culture and architecture are normally the problem. So with that in mind, I'm going to basically present DevOps as a series of myths which are wrong. So a lot of people think that DevOps means firing our testers, firing sysadmins, and then hiring magical DevOps unicorns. But where do we find the unicorns? Well, we go to the field of dreams, and we bring the unicorn bait, and they magically come. Well, no, that's not how DevOps works. DevOps is a philosophy, a way of thinking about how to solve problems. It's not hiring the DevOps. It's not buying the DevOps. It's not getting the DevOps consultants. The people who you need to succeed are already in your company. There's a great story from Adrian Cockcroft, who ran cloud architecture at Netflix for a long time. He would go and give talks at big companies, and the CIOs of the companies would come up to him afterwards and say, "Adrian, where do you get your amazing people from?" And Adrian would turn around to them and say, "I get them from you." Because guess what? There is no such thing as the mythical 10x developer, where if we just hired enough 10x developers or DevOps people, we would be in the land of fairies and unicorns. The biggest obstacle is your own organizational culture and leadership, not the people that you have. People love, so this isn't DevOps. People love reorging. What reorgs do is create chaos in the organization for several months as people work out what the hell they're supposed to be doing. So you incur a massive productivity hit, and then gradually you move back to the baseline level of productivity you had before the reorg, and then so it goes negative, and then it climbs back up to 0. So that's what typically happens in a reorg. Meanwhile, you lose like 3 to 6 months worth of productivity while everyone's working out what the hell they're doing. DevOps isn't about reorgs. DevOps is about changing people's behavior and how they interact and communicate with each other. You can do that without any reorgs. People think that we're going to have to rewrite our entire architecture, all our systems in a cloud-native way in AWS. So I'm not going to lie to you. Proper service-oriented architectures written in a cloud-native way are great, and they have many good properties. You are not going to wait until you achieve this magical nirvana before you can get anything done. This needs to be done incrementally. There is nothing wrong with lift and shift. That will get you some of the way there. We need to take an evolutionary approach, not a big bang, move everything to the clouds approach. I'm sorry to give you the terrible news that buying Puppet Chef Cloud Bees and Docker and Kubernetes is not going to magically make the DevOps. Tools are great. Tools are important. My main advice is don't use terrible tools. So people sometimes say, should I use GitHub or Bitbucket? And I say, yes, you should use GitHub or Bitbucket. Just don't use ClearCase. So just don't use the bad tools and you'll be fine. As long as you use one of the tools that's not horrible, you're going to be okay. People waste appalling numbers of cycles fighting over like crazy optimizations that are totally unimportant in real life. A lot of developers seem to think that DevOps means giving them root in prod. That's a terrible idea too. Nobody should have root in prod. Certainly not developers, but nor should sysadmins or anyone else have root in prod, because prod should be destroyed and recreated purely using automated scripts, using information in version control, using a deployment pipeline, and nobody should be logging in unless they have first requested a one single-use token and then logged in, and then that should result in their bash history being emailed to everyone so that we can fix whatever problem it was we found triaging. So root login should be single use for triage purposes only. All changes made to our production environment should be done through a deployment pipeline, and our infrastructure ideally will be ephemeral so we can kill it and re-provision from scratch using our deployment pipeline. So these are all things that people think that DevOps is, but it isn't. What is DevOps? Learning to work in small batches, number one. So people love big bang solutions. They love them because it makes them feel powerful and important, and it means we can spend a lot of money and have big arguments and create huge empires and dynasties like emperors. But actually, effective change is done incrementally over a long time, and it's boring, and that's good. Boring is what we want. So learning to take big things and split them up into small incremental chunks that get us some of the way there, that's how you should do everything, whether it's product development or organizational change. Work in small batches. People hate doing this. Developers, I could literally spend every waking hour fighting with people over trunk-based development versus feature branching on Twitter. What I do instead is anyone who argues with me, who I've argued with before, I mute them on Twitter. That happened only this morning. That Dan North is currently fighting a rearguard battle against someone who's been trolling me for years about this. And I think he gave up, which is, when Dan North gives up, we're all doomed. This is an ongoing battle, and I've been talking about this for 15 years, and every year a new generation of people graduates from grad school, and we have to have this whole battle all over again. So getting engineers to understand how to work in smaller increments off trunk instead of putting on their headphones and disappearing into a crazy rabbit hole of refactoring and gold plating for days on end to emerge flushed and excited with some new enormous wodge of code that they're going to somehow wedge into your production environment. Developers don't like to hear that that's a terrible idea. They like doing that. And so someone has to break the bad news that no, you actually have to talk to other people on quite a frequent basis in order to build complex systems as a team. So this is hard. Managers don't like it. The way that people become VPs is by winning huge political battles over billion-dollar budgets, not by slowly, gradually, boringly, incrementally introducing change. So this is news that nobody likes. Sorry about that. Projects in particular are really evil. A paper that I really like is called Black Swan Farming, using cost of delay, from which this is taken, and I've very rudely not put the reference on the bottom of the slide, for which I apologize, but if you Google Black Swan Farming using cost of delay, this is a case study that was done at Maersk, the world's biggest shipping line, and mainly because the other ones seem to all keep going bankrupt. So they analyzed their entire backlog of features, of which there are between 3,000 and 4,000. And they basically, things just stayed in the backlog for months until they get batched into projects and delivered. And they got all the stakeholders into a room and went through every one of those requirements in a few days and basically measured them using a technique called cost of delay, which I won't go into now, but basically what it is how much money are we losing every week by not delivering this feature? So you quantify, to the nearest $100,000, how much money we're losing by not delivering this feature. So if we deliver this feature, we could make this amount of money. Because it's not delivered yet, we're not making that money. It's an opportunity cost. And so, you don't need to be very accurate. People often fret about, are we accurate to the last dollar? As we will find out, that's utterly irrelevant. So to the nearest $100,000, and what they found is there was these 3 features which by not delivering them was costing them between $1.8 and $2.8 million per week that they hadn't delivered them. And then there was this long tail of features where the opportunity cost was $400,000 or less. Now, you don't need to know the opportunity cost to the last dollar in order to determine that what you should do is stop all work that isn't devoted to delivering these 3 features and deliver them as soon as you possibly can. Joshua Arnold, Özlem Yüce, who wrote this paper, they've been doing this at a bunch of different places, and this kind of shape is very common. This is called a power law distribution in statistical terms, and this is basically what you see everywhere. There's a few features which are really important, and then a whole long tail of stuff that's not that important. And it's all stuck in projects, and all the projects get delivered at the same glacial pace. And what happens is, I want to get my project done, so I'll go over here and talk to the networking team and be like, hey, can you make this networking configuration change so I can get this test environment up? And they're like, okay, sure. And then that pushes someone else's work to the back of their backlog, which slows down some other project over here. Then whoever's in charge of this project gets mad and comes to the some other team, like the DNS team. Can you get this DNS setting fixed for me? Oh, okay, sure, yeah, I know you, I'll get that done. And then some other thing gets sent to the back of the backlog because of that, and then this team back here gets blocked by that thing. And so what happens is everyone is doing like manual reprioritization at the lowest levels of the organization, and the net result of that is zero sum, which means that everyone is still moving at the same glacial pace and nothing actually gets prioritized. So this is the problem with projects. You batch up stuff so it all gets delivered at the same time. Everything moves at the same glacial pace. Meanwhile, everyone is really mad at everyone else for not getting their stuff done and nothing happens. So getting insight into what the organizational priorities are and getting an enterprise level backlog which is prioritized and making sure we're working on the things that actually matter and delivering those things as soon as we possibly can is the solution to this problem. That requires collaboration and transparency and effective communication and prioritization. Managers and leaders hate doing that. Who's been to a manager and said, please prioritize these things, and they've said they are all priority 1? Right. Who has seen the same manager eagerly stack rank the engineers at performance review time? Managers love prioritizing people, and they hate prioritizing work. What if it was the other way around? Wouldn't that be a better world to live in? So yeah, making sure we actually prioritize work and that we work on the most high priority things is super important. People hate doing it. I talked about strangler application before. I'm not going to talk about that again. I will add some rules to this, so incremental architectural change. And again, this is all about small batches. So he talked about small batches in projects, working in small batches in projects. working in small batches for architectural change. When you're doing evolutionary incremental architectural change, these are your rules. Number one, start by delivering new stuff at least at first. Don't rebuild the existing stuff. That's always terrible, especially when you take the system as it exists and rebuild it exactly the same as it was, but in a new technology. Who's seen one of those where it's like, we're going to rebuild the system exactly, it looks exactly the same business processes, different stack? Who's done that? All right. Who has actually watched their users try and interact with the systems that they build? Okay. So, I mean, my experience is, who's been to a bank to open a bank account? All right. And you go into the bank, and you talk to the teller, and they go to one system and they type some stuff in, then they close that window, open a completely different system, type stuff in, write down some of your personally identifiable information on a post-it note, and you're like, please throw that away and shred it at the end, but they probably don't. It probably goes home stuck to the outside of their bag. And then they write something else down and go to a third system and then come back to the first system. So it's a disaster, basically. The life of your users is miserable, and you should go and watch them because it will make you sad, and then hopefully you will do something about it. But then, like, you look at that, and then it's like, rebuild the system exactly the same. It's like, oh, great. Now the tellers still have to use 3 different systems to open a bank account, but now it's in Node.js. Woo! So if you're going to rebuild stuff, don't rewrite existing functionality unless it's to simplify, by which I mean to actually serve a business process as it exists now. Don't ever rebuild to serve a business process as it existed 10 years ago when the software was first written. Always build user research into existing functionality rewrites. The key goal when you're doing a re-architecture is to deliver something fast. So again, tell me if you've heard this story before. Some senior architect or VP comes in with like, in 2 years, the enterprise architecture will look like this, and there's a huge diagram which looks really beautiful. And you get about 1 year into the re-architecture, and you're like, so, how much longer? And they're like, well, still about another 2 years. And then you get another year in, and you're like, well, how much longer? And they're like, well, still probably another 2 years. And if you're really smart, that's the point at which you quit, because sure as hell, that's what the VP is going to do before the project gets canned by the senior executives. So again, avoid that. Deliver some incremental improvement fast. Don't do big bang re-architectures. They're always terrible. Make sure you design for testability and deployability. And try and rebuild the new thing on a platform as a service rather than, creating an entirely new stack with custom infrastructure using custom scripts, because that will be a total disaster to maintain. So, talked about projects, small batches, re-architecture, small batches. I want to talk about organizational change, small batches. The thing to remember here is that your organization is composed of people. And people have different attitudes towards change. So this is based on some research on technology adoption that was done by Everett Rogers at Iowa State University, which then became very popular because Geoffrey Moore took Everett Rogers' ideas and put this little hole in the middle here. And so here's the idea. There's a whole bunch, small percentage of your people who are really into shiny objects. And they always have the latest gadget, and they love the new thing. They will be the first people to try ideas. If those people are successful, this next group will try these ideas. If those people are successful, this early majority group who like to, they're not going to be the first people, but if they're in the majority, they're happy. They'll adopt it. Then you've got conservatives who like to stick with a proven way of doing things. Then if these people are successful, the conservatives will adopt it. And then finally, you've got these people who we all know, who are the people who still insist on checking all calculations on their 1970s HP calculator, who still have flip phones if they have mobile phones at all, and they just hate all new things. So here's the thing. You can't roll out enormous process changes to the whole organization in one go, because all these people here will basically stop the whole thing in its tracks. they will act as an anchor that will prevent you from doing anything. You've got to respect the fact that you've got to target these people first. They've got to succeed, which will target the next group. And then when they succeed, you'll target this next group. So you've got to roll it out incrementally. And the gap here is because if you don't do it fast enough, the new shiny thing will come along before the thing you're trying to push crosses the chasm, and then it falls into the chasm. And whatever Docker is in 5 years' time is going to be whatever these people are focusing on, if you didn't make Docker part of the majority of your production systems by that time. So you've got to achieve a certain level of momentum when you're pushing out organizational change without doing it all at once. So working in small batches for everything. Number 2, create fast feedback loops. The whole point of the deployment pipeline, of having automated tests, all this stuff is about creating fast feedback loops. The reason we create fast feedback loops is so that we can respond to our environment as fast as possible. Continuous delivery gives you velocity. But with velocity, you need the ability to course correct rapidly. If you build a car where there's a 1 second lag between turning the steering wheel and having the car change direction, and you try and go at 100 miles an hour, you will crash. So you need responsiveness if you're going to move fast safely. Feedback loops are what give you responsiveness. That's why you want to know the moment you introduce a bug, before you check it into version control, rather than a month later when the QAs do their manual regression test, because you want to find the problem before it ever goes into version control. Another key piece around DevOps is enabling cross-functional collaboration across the whole value stream. The biggest problem in siloed organizations is that people don't trust each other, number 1. And number 2, they're measured in ways that bring them into conflict. When developers are measured by throughput and ops is measured by stability, they're never going to collaborate effectively together, because what makes them successful brings them into conflicts with other groups. So the solution to this is not necessarily reorging. It might just be creating teams for single products or services where all those people sit next to each other in the same room. So have the testers and the developers and the ops people for a single service sit together in the same room. You don't need to do any reorging to do that. You just need to say, hey, you're going to be in this room tomorrow, along with these people. No changes to the organizational structure need to take place in order to do that. Now, that's neither necessary nor sufficient, because goodness knows, you can sit people next to each other and they can still hate each other and never talk to each other. So, that's not going to solve your problem. That's just one technique that you can use that might help you. Ultimately, again, people have got to work together because they want to work together, because it's in their interest to work together. That's the outcome you're trying to achieve. And you can do all kinds of things which sound like a good idea, which don't achieve that outcome. A really important piece is making it safe to fail. So this morning, I showed you this graph here, this chart, sorry, from Westrom's typology of organizational cultures. And I talked about how we want to be in this right-hand side of generative, performance-oriented organizations. And I talked about how attitude to failure is really important. Failure shouldn't be punished. Failure should lead to inquiry. How can we get the people who need it better information, better tools, so that when the same thing happens again, it doesn't lead to a catastrophic outcome? So Google did some research into how to build high-performing teams at Google, and they thought it would be 3 Stanford graduates and 2 Node.js developers and, I don't know, an SRE. What they actually found was that the most important factor in creating successful teams at Google was psychological safety. And the reason is, if your team doesn't feel psychologically safe, they won't innovate. They won't try new things because it's risky and they're scared of failing and getting told off or fired or punished. So this is real. You've got to create an environment where people feel safe, because otherwise they won't try things out. How we deal with failure is really at the heart of DevOps. Disasters shouldn't be treated as terrible things. They should be treated as learning experiences. One of my favorite stories to come out of Silicon Valley is the disaster recovery testing stories. So this thread starts with Amazon. Amazon's master of disaster, Jesse Robbins, was a volunteer firefighter in his spare time. And he realized, in firefighting, you run fire drills. You simulate a fire, and then you see how long it takes for everyone to get out of the building. You make sure everyone knows what to do. You practice. So he thought we should do this for our disaster recovery testing. And so he went into work one day and said, okay, everyone, in about 6 months, I'm going to power down one of our data centers, and you all have to keep your services running. And everyone said, ha, 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 Jesse, you're so funny. And then they realized he was serious, and they were really scared. But this is actually something that happens and continues to regularly happen. They really actually create disaster scenarios to prove that they can do them. At Google, there is a disaster recovery testing team led by this woman, Kripa Krishnan, which creates whole scenarios like aliens invading Silicon Valley. And they actually execute them over a 72-hour period in order to get the team to understand how to manage in a disaster scenario. So they do this every year. You should read this article by Kripa Krishnan on this slide. One of the things she says is this: for disaster recovery testing and style events to be successful, an organization first needs to accept system and process failures as a means of learning. We design tests that require engineers from several groups who might not normally work together to interact with each other. That way, should a real large-scale disaster ever strike, those people will already have strong working relationships. So one of the goals of disaster recovery testing exercise is to create collaboration and communication and relationships. Again, it's a people problem, not a technology problem. Who has actually executed a real disaster recovery testing scenario for their production systems in the last year? Okay, if a few of you, that's pretty good, like maybe 20%. So it's like backups. A backup that you haven't restored is a backup that is of zero value. It's the same with disaster recovery testing. If you haven't actually executed your disaster recovery testing scenario, it's not real. And it's not just about doing that, it's about making it normal so people know what to do and they don't panic. They're like, oh, here's the run deck, here's the phone numbers I'm going to call, let's all get on Slack, off we go. Etsy actually gives out an award every year to the person who causes the biggest production outage at their developer conference. It's do you call it a sweater or a jumper in the US? A sweater with 3 arms, which is the 404 page on Etsy, by the way, is a sweater with 3 arms. They give a sweater with 3 arms to the engineer who causes the biggest outage, and there's a celebration. There's a woman called Catherine Daniels, who used to be an ops person at Etsy. She has a great blog post about how she won the award one year. And basically, one of the things she says in it is, what was great was, once I realized something was bad, I went onto Slack and said, this has happened. Everyone jumped on and said, how can we help you? And they solved it together, and they held a blameless post-mortem, and they found out how to stop that happening again. She wasn't fired. She got a sweater. If there is insufficient stress on your systems, you should work to create more. This is the whole goal of Netflix's Simian Army, to actually create stress on your system, to validate that your systems are actually resilient. So I'm sure everyone's heard of this. If you haven't, they actually randomly kill off servers or even whole availability zones in Amazon randomly on a schedule to prove that the system is resilient to partial failures. Finally, DevOps is continually working to remove waste and make things better. So I'm kind of running a bit short of time, so I just want to briefly talk about a case study from a very different domain. So this is HP LaserJet firmware. This is building firmware for printers, and they had this terrible problem that it took a year to get It took more than a year to get a new firmware build for a new line of printers. And they were on the critical path for over 10 years, the firmware team. Every time they wanted to come out with a new line of printers, the firmware team would be the last people to get their stuff done. And it was causing them to not be competitive with Lexmark and the other competitors in the market. So they tried hiring people and firing people and insourcing and outsourcing, and nothing worked. And they were so desperate, they went to engineering leadership for help, which is how you know things are really bad. And what engineering leadership did, which was fascinating, was that they looked at what people were spending their time doing. So in 2008, they looked at engineering costs, and they found that 10% of engineering costs were spent on code integration, 20% of costs were spent on detailed planning. This was basically because the product people would get super mad that the engineers couldn't get anything done and ask them to give them detailed multi-page reports on exactly why they were so slow and do this very detailed estimation so they could explain why they were so terrible. And then they'd get 6 months through the year, realize they couldn't even do the one thing they had committed to, and then have to do a detailed replan. This was consuming 20% of the engineering time. Every time they created a new line of printers, they would port the code across a different branch. So create a different branch for that line of printers, port the code over. Anytime you have a bug fix that impacts multiple lines of devices, you have to port that bug fix across all those branches. Every time you have a feature implemented on multiple lines of devices, you have to port that feature. That's taking 25% of engineering time. 25% of engineering time is spent on product support. What does this tell us? Quality problems, great proxy variable for bad quality. 15% of their engineering budget was spent on manual testing. You subtract that from 100%, you're left with 5%, which is the time they had to build features. So you wonder why they are so slow. Who has heard from their manager, we would love to invest in automation and refactoring, but we don't have time? Who's heard that? Okay, so the fallacy in that argument becomes brutally clear when you look at something like this, and you see that unless you actually invest to remove this waste, you're going to be in a vicious cycle, which is going to end up with you getting nothing done whatsoever. So lean, people think lean is about cutting costs. Lean is not about cutting costs. Lean is about investing to remove waste. So you've got to invest in reducing non-value-add waste, and that's going to increase your capacity. So they basically did a complete re-architecture, the thing that 10 minutes ago I told you never to do, so hey. And they re-architected the entire system, basically because they were desperate and they tried everything else. They re-architected the entire system on a new technology platform, but they rebuilt it with a very different set of architectural goals. They wanted to be able to have a single build that they could put on any line of printers, and it would basically switch functionality on or off using feature toggles based on the hardware profile. So Boots looks around, oh, I'm a printer, I'm going to turn off these things. Boots turns on, oh, I'm a scanner, I'm going to turn on these things. So in this way, we can have a single build that runs on any line of devices. Then we don't have to have all these branches for these different devices. Then we can do continuous integration. They also then invested in large amounts of test automation. And they actually built a simulator so that you could simulate the hardware platform on your development workstation. That was a substantial engineering effort. They have these custom ASICs, which are very complex custom chips with more transistors than a CPU. They built a simulator so that you could run the firmware on your desktop as a developer, so you could reproduce automated test failures, and so they could run acceptance tests in parallel on huge banks of computers. And basically what they did is, before this, they had a 2-week regression test cycle. And they completely got rid of that, basically by building a deployment pipeline and then reproducing test failures on developer workstations. So you can read about this by going to continuousdelivery.com, going to the case studies, looking up the HP LaserJet firmware case. But the net result was this. 3 years into this, they were spending 2% of their budget on continuous integration instead of code integration, Planning goes down from 20% to 5% because they stop doing this detailed planning. They just do very high-level, low detail planning. Porting code goes away. They're still spending some of their money on maintaining their main branch. Product support goes down from 25% to 10%. What does this tell us? Higher quality. Most testing is automated, and they achieve an 8x improvement in innovation productivity measured in terms of budget spent on innovation. So 8x productivity increase. What do you notice about these numbers on the right? Anyone paying attention who knows arithmetic? Correct, doesn't add up to 100%. That's because there's a new activity. They are spending 23% of their budget on creating and maintaining automated tests. What would your management say if you went and asked for 23% of your budget to spend on test automation? And yet, they were able to do that and achieve an 8x productivity increase measured in terms of budget spent on innovation. So very simple tools, activity accounting, investing in continuous improvement, managed to achieve an incredibly powerful breakthrough result. And what I love about it is they wrote it up into a book, which you can buy by Gary Groover, who was here actually in the last couple of days. Then he wrote a shorter book for managers, which came into about 120 pages. And then he wrote a third book, which is less than 100 pages with lots of pictures for the executives. So you should go and get those books. They're really good books. I have to finish up, I think. Questions? We probably have time for 2 or 3 questions. Yes?
The keynote this morning, you mentioned the waterfall.
Mm-hmm.
So on the business planning side of things, like before the engineering team even steps in, what strategies have you seen work to kind of have that into waterfall like?
So I think you have to fix the velocity problem first. There was a really nice case study that was done. Let's see if I can find it. So thank you. The question is, what do we do about all the upstream inefficiency around the planning process? Let's see. There we go. So this was some work that was done, that was published in MIT Sloan Management Review about what's called the alignment trap. And what they looked at is 2 things. Alignment between the business and IT, and then efficacy, how efficient, or not efficient, how effective IT was. And they looked at this whole cohort of people, and they looked at 2 measures, IT spending and compound annual growth rate. This was 74% of their cohort in this maintenance zone. 7% of their cohort is up here, highly aligned, highly effective, much higher compound annual growth rate, lower than baseline spending. How do we get from the bottom left to the top right? Well, it turns out if you try and pursue alignment before pursuing effectiveness, you end up spending more money but with lower growth. Whereas if you pursue effectiveness before you pursue alignment, you end up with lower spending and higher growth. So it's like, I talked about the car. If you don't fix the steering, if you can't move fast, you can't pursue the alignment. This metaphor is really broken down for me. It's been a long day. What can I say? Like you've got to make the thing efficient before you can get the alignment working. So you've got to be able to respond quickly to changes in customer demands. Okay, it's like the feedback loop. The metaphor is kind of wrong because I'm thinking of efficacy as velocity, which it's not. It's not efficiency, it's effectiveness. So you've got to be able to have those feedback loops so you can respond quickly to change before you can try and align with the business. Otherwise, if the feedback loops are too long, by the time you get something built, the business won't want it anymore. That's the way of thinking about it. So you've got to get the IT performance high and get those things moving quickly before you can pursue alignment. So I would say implement the continuous delivery stuff first, otherwise you end up in the HP LaserJet firmware situation where, because it took them so long to get anything done, they couldn't pursue alignment because they just couldn't get anything done. You've got to be able to get stuff done and be effective before you worry about alignment. So fix that problem first, fix IT performance first, then you can pursue alignment. And then I really recommend going and reading that paper which I failed to reference, which is Black Swan Farming, Cost of Delay, which has this nice graph in it. Having an enterprise level backlog which is prioritized so that everyone has transparency into what the program level priorities are is really important. There's a whole talk I've got on YouTube called something like why scaling agile is dumb and what to do about it. If you go to continuousdelivery.com, go to the talks page, there's a whole talk on like why scaled agile is a horrible idea. I talk about exactly this problem there. Okay, that was a very long answer. If it's a quick question, we can take it. Yeah. Thank you. Yeah, all my stuff is on SlideShare. Send an email to jezhumble@sendyourslides.com with the subject DevOps, and you get like all my free stuff, of which there's a slightly terrifying amount actually. So yeah, subject DevOps to jezhumble@sendyourslides.com. All my slides are up there. This one isn't quite up actually, but I'll put it up today. But you can send the email anyway, and then check on SlideShare in like a day or so, and it'll all be there. All right. Thanks very much for your time.